Is the universe twice as old as we thought? Does this mean we have to rewrite the entire history of the Big Bang? In this video, we explain why cosmology is currently being shaken up, so be sure to stay tuned until the end for a space-time identity crisis. Welcome, friends. Okay folks, if this is really true, it's going to throw all our theories about the cosmos out the window. The universe is supposed to be twice as old as we thought. Let's try to get this video 600 likes so it can be shown to even more people who can then also have a cosmological crisis. Until now, the following scenario was assumed. The universe is 13.8 billion years old and began back then in a singular event, the Big Bang. Since then, the cosmos has been expanding. This expansion is mysteriously accelerating and nobody really knows why. This is why the idea of dark energy has been developed, an ominous force that is driving the universe apart. So much for the very rough outline of the current state of cosmology. How do we actually know how old the universe is? I mean, we can't even determine the exact age of certain footballers who are probably 30 years older than they claim.
Wir wollen nur nachfragen, ob das in Ordnung geht bisher, das Ergebnis.
Ja, alles in Ordnung. Ergebnis eigentlich verdient. Für die anderen, aber beide hat wir nicht mal zulegen.
Was haben Sie denn da unten in Ihrem Stutzen drin?
And we want to say exactly when the birthday of the universe was. In fact, this is possible using quite fascinating methods. One of the most important discoveries that help to determine the age of the cosmos is the observation of cosmic microwave background radiation, or CMB for short. This almost uniform radiation is the afterglow of the early phase of the universe and fills the entire universe. The CMB was first discovered in the 1960s and provides a direct view of the universe. Only about 380,000 years after the Big Bang, the moment when the universe became cool enough for protons and electrons to combine to form neutral atoms, allowing radiation to travel freely through the universe. This is a relatively safe method. We simply look into the past. The detailed analysis of the temperature fluctuation within the CMB by satellites such as the Cosmic Background Explorer or the Planck Space Telescope has enabled scientists to measure the expansion rate of the universe, known as the Hubble constant, very accurately. I can already hear some of you saying that.
Dude, get to the point. How old is the universe now?
Take it easy. To understand why some people are now saying that the cosmos is twice as old, it is important to understand these basic principles. And now that space is already several billion years old, we don't need to rush, and the precise measurement of the Hubble constant mentioned above is essential. The universe has been expanding continuously since the Big Bang. That is pretty indisputable. The Hubble constant describes the exact rate of this expansion by measuring the speed at which galaxies are moving away from us. Astronomers can calculate this expansion rate as a function of their distance from us. Knowledge of this constant then makes it possible to calculate backwards and estimate the age of the cosmos. Although the exact number of the Hubble constant varies between different measurement methods, they lead to a similar estimate of the age of the universe. A bit like if you know exactly that your grandparents can walk 1 meter per minute with their walkers and they are both standing 10 meters away from each other. Then you can calculate back that they set off 5 minutes ago. Okay, I really need to come up with better comparisons. There are other methods, but the most important point is that you always come to similar results with all of them. Namely that the universe is about 13.8 billion years old. And now physicist Rajendra Gupta from the University of Ottawa in Canada bursts into this scientific harmony and claims a new study. No, the universe is almost twice as old and all other cosmologists would be fooled by an optical illusion. That's how you make yourself popular in the academic world. He says, the results of the study confirm that our earlier work on the age of the universe of 26.7 billion years has allowed us to discover that the universe does not require the existence of dark matter. What is dark matter? We have already talked about dark energy, which is supposed to explain the expansion of the cosmos. Dark matter, on the other hand, was introduced to explain the rotational speed of galaxies and the mass distribution in the cosmos, which cannot be explained by the matter we know. So there is both a force that drives the cosmos apart, which we don't know, and a force that holds galaxies together, which we also don't know. Oh yes, and to get there, dark matter would have to make up 85% of all matter in the universe, but it has not yet been found directly. Well, and Rajendra Gupta now says that with his theory of the age of the universe, we don't need dark matter or dark energy. According to the new study, the existence of dark matter and dark energy may be a consequence of incorrect assumptions about the age and expansion of the universe. Instead, the observed accelerated expansion of the universe may actually be a result of the weakening of gravitational forces over time rather than due to the action of mysterious dark energies. And this interpretation could also eliminate the need to resort to dark matter to explain the gravitational effect within galaxies and galaxy clusters. So far, so practical, because if we remove these gap fillers from the equation, that would be great, as we would no longer have to struggle with the detection of dark energy and matter. It's like if someone told you your whole life that the reason you weren't successful was dark destiny, and then one day you realize that was a complete fabrication and that there is no such thing as dark destiny, and the real reason you're not successful has been that you're lazy all along. According to the study, the conventional measurement of the age of the universe, which dates it to about 13.8 billion years, is influenced by an optical illusion. This illusion results from the assumptions we make about the way light and gravity interact across immense cosmic distances. Gupta says, in standard cosmology, the accelerating expansion of the universe is attributed to dark energy, but it is actually due to the weakening forces of nature as it expands, not dark energy. I also feel the weakening forces of nature every morning when I get up, but in this case, he is alluding to so-called light fatigue. This is an idea that was originally proposed by Swiss physicist Fritz Zwicky in the 1920s. This theory claims that the redshift of galaxies is not exclusively caused by their movement away from us and thus by the expansion of the universe, but also by a gradual decrease in the energy of light as it travels through space. In other words, the further photons, i.e. particles of light, travel through space, the more energy they lose, i.e. the more tired they become. Gupta has added a few more factors to the light fatigue theory, but in principle the entire study is based on the fact that photons become tired the longer they travel through the cosmos. And this is where the study meets with considerable criticism from physics colleagues, as light fatigue has been considered disproved for decades. Fritz Zwicky developed the concept in order to reconcile the redshift of light from distant galaxies with a static, i.e. non-expanding universe. At the time, this still corresponded to the recognized standard model of cosmology. Critics of the static universe were sometimes even vilified. When the idea of the Big Bang and the expanding cosmos emerged, it was even dismissed as ridiculous by experts. So much for trust the science. But today we know with great certainty that the universe is not static, and that the redshift can be explained by the fact that most galaxies are moving away from each other, and so there is no longer any basis for the light fatigue hypothesis. Another argument against it, if light were to become tired, the optical information that light gives us would also become less sharp. Is that the case? Nope. Take a look at this curious galaxy here called Hoag's Object. It's a ring galaxy with a stellar ring around the galaxy's core. In the image we can see another galaxy that is much further away. That's why it appears much redder, because of the redshift. Is this much more distant galaxy somehow blurrier than Hoag's Object in the foreground? No. Light fatigue is therefore disproved by this image alone. I am therefore of the opinion that the new study is very interesting, but, as they say scientifically, it is nonsense with gravy. But feel free to write your opinion in the comments. Is the universe perhaps older than we think? Is our current measurement of 13.8 billion years completely wrong? Write all your ideas and weirdest hypotheses in the comments. I'm super excited. If anything happens in cosmology, I'll keep you up to date immediately, but that's only possible if you follow my channel. Subscribing is absolutely free. You'll never miss another galactic video, and it helps me immensely. Be sure to click on the video in the top right-hand corner to find out some crazy theories about dinosaurs on the moon. And if you want to support my work, feel free to visit the Astro shop and get your own cute plush planet. Otherwise, I'd say see you in the next video. Take care, friends.